Mode of binomial distribution. Now, binomial distribution can be bimodal or unimodal depending upon the whether n plus 1 p is an integer or not. The mode of binomial distribution is given by m, m minus 1 if n plus 1 into p is an integer, or where m is equal to n bracket starts n plus 1 bracket close into p. Mod is equal to m if n minus 1 into p is not an integer, where m is equal to a integral part of bracket starts n plus 1 p. Now proof: p bracket starts x is equal to r bracket close upon p into x is equal to r minus 1 is equal to ncr p raised to our q raised to our n minus r upon ncr minus 1 p raised to our r minus 1 into q raised to our r minus n q raised to our n minus r plus 1, that is equal to n factorial upon n minus r factorial into r factorial p raised to power q raised to n minus r upon n factorial upon r minus 1 factorial into n minus r plus 1 factorial p raised to r minus 1 and q raised to power n minus r plus 1. So which is further equal to n factorial upon n minus r factorial into r factorial p raised to power r q raised to power n minus r, and this term will be r minus 1 factorial into n minus r plus 1 factorial upon n factorial into p raised to power r minus 1 q raised to power n minus r plus 1. So that is equal to n factorial p raised to power r minus r plus 1 q raised to power n minus r minus n plus r minus 1 upon n minus r factorial r into r minus 1 factorial into r minus 1 factorial into n minus r plus 1 into n minus r factorial upon n factorial, that is equal to p into q raised to power minus 1 bracket starts n minus r plus 1 bracket close upon r. So that is equal to n minus r plus 1 bracket close into p upon r into q. So r into q plus bracket starts n minus r plus 1 bracket close p minus r minus q upon r upon rq, that is equal to 1 plus bracket starts n plus 1 bracket close p minus rp minus rq upon rq, that is equal to 1 plus n plus 1 into p minus r bracket starts p plus q bracket close upon rq, that is further equal to 1 plus bracket starts n plus 1 bracket close p minus r upon rq, because p plus q is equal to 1. So in place of p of q we only write here 1 r into 1. So by the definition, mod is a value of x at which the px is maximum. Now two cases arise. Case 1, when n plus q into p is not an integer, let n plus 1 into p is equal to m plus f where m is an integral part of bracket starts n plus 1 bracket close into p, and f is an fraction part of n bracket starts n plus 1 bracket close into p is such that 0 is less than f is less than 1. Therefore p of x equal to r and p of x is equal to r minus 1 is equal to 1 plus bracket starts m plus 1 f m plus f bracket close minus r upon r cube, which implies p of xr upon p of xr minus 1 is greater than 1 for r is equal to 0 1 2 so on m, and p of xr or p of xr minus 1 is less than 1 for m plus 1 m plus 2 and so on. So which implies p of xr upon p of xr minus 1 is greater than 1, and p of x1 upon p of x0 is greater than 1, and so on. P of xm upon p of x is equal to m minus 1 is greater than 1, and p of x is equal to m plus 1 upon p of x is equal to m is less than 1, and p of x m plus 2 upon p of x m plus 1 is less than 1, and so on. P of x equal to n upon p of x equal to n minus 1 is less than 1. Therefore p of x0 is less than p of x1 is less than is so on. P of x m minus 1 less than p of x x equal to m greater than p of x m plus 1 greater than p of x m plus 2 is greater than so on. P of x is equal to m. So the p of x is a maximum at x equal to m. So mod m is n plus 1 into p is not an integer, and m is an integral part of bracket starts n plus 1 into bracket close into p. In the second case, if n plus 1 into p is an integer, so let n plus 1 into p is equal to m. So p of x r upon p of x r minus 1 is equal to 1 into m minus r upon r cube, which implies p of x r upon p of x r minus 1 is equal to greater than 1 for r is equal to 0 1 2 and so on. M minus 1 is equal to 1 for r is equal to m, and is less than equal to 1 for r is equal to m plus 1 m plus 2 and so on. And therefore p of x is 0 is less than p of x1 is less than so on. P of xn so is equal to x is equal to m minus 1 is equal to p of xm is greater than p of x is equal to m plus 1 greater than p of x is equal to m minus 2 is greater than so on. P of xn mod is m minus 1 and comma m if n plus 1 is into p is greater than integer. Therefore the binomial is a bimodal.